Good evening, everybody. It is a Saturday night, my friends, and I'm back for some more coding stuff as usual on a Saturday night. Welcome on in, everybody. Welcome. I hope everyone is doing well. Hope your weekend has been good so far, and getting all the rest and other things you might need along the way. But welcome on in, everybody. One moment while I get my stuff together here. Alright, let's bring this up. Yeah, it's Saturday night, friends, and I'm gonna start standing up tonight. So that's why the webcam isn't on, because you would just see my chin probably. I still haven't figured out how to properly webcam where I'm standing versus sitting, and even sitting is kind of a not even necessarily a proper webcam, but you know. It's something. Anyway, friends, last night we made a decent amount of progress, I would say. We're getting through this kind of weird thing that they're doing, where they are reading in the model files and then generating a couple JSON files and a couple binary files. Well, a JSON file and a couple binary files for whatever reason. Instead of just putting them all in just one JSON file, if that. And of course, obviously, the textures have to be in a PNG kind of file or something like that. So that I can understand, but the rest of it is kind of weird. I assume that this is more of they're trying to perhaps save memory. You know, obviously, I mean, in the grand scheme of things, you probably don't want to be having to load the models up from the model files every time. So I guess they're just trying to come up with a less intensive solution, which certainly writing them out as JSON would cover that. Though, for whatever reason, they went with Google's JSON stuff, which is it's not the worst thing in the world, but it's also kind of silly, because you have, when in a world where Jackson exists, in particular Jackson data mapper, is it data objects, whatever it's called. In a world where that exists, it's kind of silly to use anything else, because it comes down to, like, Jackson can write the JSON out just fine, and more importantly, it can just read it right on in to a Java object, right? So why you would use anything else is just kind of it's a little bit strange to me. I assume JSON has something similar. I've never really used it that much. But it's also kind of they're not using it that way. Well, I mean, they might be using it that way for one part of it, but then they're using just serialized output files, binary output files for other stuff, which is a little strange. I'm not sure why they're doing it. I think their thought process was they were going to read them directly into buffers in memory, which is fine and well, but you're not necessarily saving yourself anything by doing that, because you can just as easily have them all, read them all in to an object and then just generate the buffers that you need as you're going. So I'm not sure that's saving anything by writing those buffers out per se, and I don't even know if they're technically doing that. So I don't know. It's just a. It seems like they went to great lengths to optimize something without checking to see if it's worth optimizing at this point, right? I mean, I guess maybe further down the line when you've got hundreds of models and hundreds of objects to load up, maybe it will optimize that way, but I don't know. I'm not convinced yet. I think that's something that I have to come to when the time is right. Right now, I'm more interested in having code that is easier to follow and not having 9,000 files all lying all over the place, you know. So that's kind of where I'm at there with that. We'll see. But yeah, I mean, all we have to do right now is write the file out. Which I'm just kind of looking at this. I don't think there's really anything crazy going on here. So I'm just going to write out the JSON file, and then that's it. So they got the material JSON here. I'm just going to write out the. So what are they using for that? They're using the. Model path, out material file, out model file. Here it is, out model file. Okay, but don't I have the file name without the extension here already? Yeah, I have it as the model ID. So I just have to use, I'll just use the model ID as the output file. We'll just say, yeah, model ID there. And then I gotta do, what was it? Objects. Object writer, it's object. Man, I can't think of it right now. Need my brain to start working. Objects. Okay. Excuse me. My brain has completely stopped here. Jackson. Object mapper. That's what it is. Okay, and I think I added everything to converted model, right? Did I? Because I don't think I've used anything here. First materials. Mesh data lists. Okay. Set materials. data, mesh data lists. I don't need the offsets at all, but the texture path I will set to, what did I call up here? Model file, I think. Is that what they set there? That's what they set their texture path to. I think. Yo, dude, what's up? How's everything? So I'm saying texture path. Oh, jeez, really? I would. Well, I mean, I guess it's the season for that, right? everyone's looking for a deal, I guess, at this point. Never again. No, I hear you. Yeah, I'm trying my best to not have to go out for too much at all right now because of all the traffic mobbed out there. Sample model file. Well, is that really the texture path though? No, it would be the. Didn't I grab the parent thing here somewhere? That's there 30 years ago. 30 to go back. Yeah. Yeah. It's oof. Just oof on that. Parent directory. Yeah, I feel like I should put parent directory there. Well, tell her hi. Everything's good on my side. I got all my blood work stuff back and everything's good. So still kicking. Okay, so I got the output file here. So what was it? Mapper. Writer for. How do I do this? So writer for Let me just give it a class. Okay, dude. I'll see you then. Oh, do I have... What's the writer... Right file... Right value. Yeah. This is... Wait. Data output... File. Here we go. Right value... Right, this should be file. Put file is new file. Whoops. Like that. And I'll say output file and convert model. I believe that will just write them out. If I remember correctly. I don't do much writing of them out. I do a lot of reading them in. But I think that will accomplish what I'm looking for. Alright, so that should write the JSON out to a file, which means I believe we're done with this class, although I think that there'd be a load here, like something to read them in. But I'm guessing they do have a model. I think they have a model loader class. I bet it's in there probably. All right, I do have an error though. Where's the error at? Oh, I don't know what that's doing there, but. I'm gonna chalk that one up to IntelliJ, not to me. Alright. So that's the model converter. Yeah, model loader. Okay. So that's what we do now. Look at the model loader. Ain't here. Load materials. Load model. Yeah, see, that's the weird thing. It's like, oh, we're gonna now you have them in two different files. You gotta load them two different ways here, and like, I don't need to do that. I can just load the whole shebang up here. So we'll do new Java class model loader. Go and we'll just say string path. So look static converted model load model string file and yeah, see, they have to like read all bytes and then JSON from JSON, content material data class, all that stuff. It's just, yeah, it's I should only have to be able to do, let's see, logger, loading, model file. Alright, and then, let's see. Let's see, try object mapper. And we'll say model equals mapper dot read value in the file. So let's do file input file equals new file model file. Import that. And then we'll just say model file goes into convert it model.class. Boom. Catch exception and time exception able to load model file. And return model. Boom. Boom, done. In fact, I don't even need to do, I don't even need to do it that way if I don't want to, but I could just return here, but I'll do it this way. So we get that. Alright. What else? What else we got going on? Alright, so that's just the modelers. That's all we need to do there then. So what else did they have in their book? So that's the end of the stuff in the model folder, it looks like. So I think it's just a matter of me going back and finding the to-dos. Although did I jump forward at some point here maybe? I might have. And some things. And obviously I gotta do the shares. I gotta test, I'll copy their cube object over and put a JUnit test together and see if that loads the JSON and everything correctly. There we go. Let's see. Input file is not being used. Oh. Oops. Glad I caught that. Okay, so I gotta find all the outs. I find all the to-dos here. So texture cache, add texture. It's in Vulkan material. Whoops, is that the right one? That's the right one. Oh, it is chapter 8. Texture cache, Add texture. Okay, I know where that's at. I think I just gave myself a clue there. There it is. Add texture. Okay. If has texture. Okay, where am I? It's called from here, load materials. Material cache. See if I can track this down again. So we have here load materials. Oh, here we go. Has texture, texture cache. Okay, I got it. So if has texture, we're doing texture, doing cache, add texture. Nope. Okay, I need the device in here. What else do I need? Device. How to tell this to? How to get it to? There's a command to get it to like show you the pop up again. What it takes. Alright, device ID. Texture path. Texture path. Okay, and then VK format. R8G8 B8A8 SRTB. Okay. So I have that, and then I need to fix this so that I pass the device in there now. Okay. So any more to-dos here? Finish this. Init textures in the renderer. Which I think is actually not in render. I think it's in I think it's in their other weird thing here. In here. No, not. I guess it's not in there. Renderer. Let's see. Build pictures. Init because I've called it something else here. Oh, it's in their scene render. Okay. Scene render. Because there's the load materials, and then there's the textures here, I think. The texture sampler. I'm trying to figure out what I skipped over here. I should have made it clearer when I did these to-dos. Let's see. Go up here. What did they change? They changed. Yeah, they added the texture sampler info. Along with a copy matrix to buffer. So the copy matrix to buffer. Descriptor layout, and then texture sampler, and then create pipeline. So copy matrix, so I don't know if I have any of those here. Let's see. I also have a scene render. Layouts. Pipeline. So I have the create pipeline here. Shader modules, info, scripter set layouts. All right, size. Wait a minute. Oh, that's the push constants range. List of push constants. Right, and then I need descriptor set layouts, which are here. Descriptor set layout texture. So I got, okay, I got descriptor sets for the vertex uniforms and for the storage, the fragment storage. It should be new. But I have now I'm all confused as to where I was going to put this stuff. So what does the scene... So I've got the texture cache there. I don't know what I was going to do with the init. Oh, these are just, oh, never mind. I know what I was going to do. These were just loading them up from I think this is just loading them up from the file. Yeah, because this is passing in the materials and stuff. Okay, so that is different. I think that's what I was going for there. So then scene render, I might have skipped over scene render altogether because there was too much stuff that I didn't have in place yet. Yeah, I think I did skip this over. So this makes sense that this is all messed up. Okay, so we have to go through and just rectify this. Yeah, because I have to add the descriptor set layout and stuff. Okay. So a little memento, friends. I have to take a short bio break. I will be right back. Enjoy the music. Alright, I'm back. Sorry for the delay there, friends. Okay, so we want to go through, I think, top to bottom, the scene render here, because I think this is the one that I skipped because there were so many other things that needed to be in place first. So, look at... So they've got the shaders there, so they got shaders. Fragment shader, vertex shader. I think I'm just going to keep using those. TV. ID text. Okay, so these are just descriptor IDs for things here. So private, static, final, descriptor ID. Final string the and what else? That format is still the same. Push constant size. I assume that's new. Yeah, push constant size is new. Buffer projection matrix, which I have in here. Or I don't have in here. I'm looking at the wrong side. So private static final int push constant size is plus size. Okay. And so we have private final Vulkan buffer. Matrix buffer. I think that's the only new one there, right? No, descriptor set layouts. Okay, so private final descriptor set layouts. Storage layout. Texture layouts. Vertex uniform layout. Okay. Alright, I added that thing in there, and then so they're creating the push constants buffer after the shader modules. Create shader modules. Wait. I already have that here. Push constant buffer equals. Oh, it's changed. Okay. Oh, yeah, okay. It's changed from that to push constant size. Okay. Alright, and what else? And right after that, they're doing the vertex, doing the layouts. Okay. Doing that before the pipeline? Yeah. So here we're doing this dot vertex uniform layout equals new descriptor set layout device new descriptor set layout info VK13 VK descriptor type uniform buffer 0 1 VK13 VK shader stage vertex bit. Okay. This dot projection matrix buffer equals, okay, Vulkan, this is the new thing we create. Vulkan utils create host visible buffer device descriptor allocator right do I have the descriptor allocator in here? No. So I think we should probably pass that in. And then, what else do we have here? So, fucking constants, matrix 4x4 size, VK buffer usage uniform, buffer bits. Descriptor ID projection. Vertex uniform layout. Okay. And we're copying matrix to buffer. get projection. Get projection matrix. So I need scene in here. Which I should have. I don't know if I have scene in here though. Scene. Where does this use that? The engine. Okay. So that's scene. Weapon scene. Okay, so this is in the engine. Renderer. The renderer doesn't have the scene though. No, it just has the window. So I guess I gotta pass the scene into the renderer now. And I'm just going to keep it in here. We'll keep it in there. I'll just pass that in. Okay. And then I'll have to pass that to... what should I call it here? The scene renderer. Yeah. Okay. So descriptor, allocator, and open scene. Scenes, we have a couple things to do there. All right. And I'll tell you what, once we get something, there's something about, how can I describe this? It's, as I'm putting these things in, there's a part of my brain that is just screaming out, like, please, for God's sakes, refactor this stuff. Because there's a lot of this that there's patterns that I see in their code and the book's code, that I don't particularly like. So, for instance, they're passing these huge objects, this, Vulkan context, this engine context, they're passing them around constantly. And most of the time for the Vulkan context, they're only using one piece of it. They're using the logical device, right? Yet they're passing this whole big shebang around. And in my brain, that's an anti-pattern, right? Because what you're essentially doing is you're saying, I have these global variables that are just, instead of making them available in some way that's maybe makes sense, we're just sort of shuffling them around everywhere. And I know that there's a portion of that you just can't get away from, certainly. I mean, obviously a lot of things require the logical device and all that stuff, so there's a part of that you can't really necessarily get around. But the problem with having that like that is that you now create interdependencies on things that maybe don't necessarily need to be interdependent. Or more likely, you are doing things, you're doing more stuff in one area than you should be doing. You're stuffing more code into one class than you probably should be stuffing into that class. Like there might be a better pattern where you pull out some of this stuff and you make them, easier to read, but maybe you make more classes out of it, right? And that's the problem I'm seeing here, is that we're like there's a lot of things that go into the scene. Obviously the surface, the swap chain, the pipeline, all this stuff. But when you push these big objects into there, you're essentially opening these, you're putting more or less, you're making visible other parts of the engine that maybe scene render doesn't need. And along the way, it becomes really easy to just start stuffing all kinds of things in there that don't belong, because you're going to do like a quick little hack here, and a quick little hack there, and a quick little hack there. And then before you know it, you've got this house of cards that's going to blow over, in a gentle wind, a gentle breeze, And I'm trying to, this is what, the problem is right now, I kind of have to stick somewhat close to what they're doing, because otherwise I'll have a hell of a time trying to figure out what has changed from one chapter to the next. But I'll tell you, when I get to the end of this book, which, boy, that's going to be an interesting day. When I get to the end of this book, I am definitely going to go through and just try and figure out what I want to do with a lot of this code. Figure out what can I move around, where does it look, where does it feel like a better place to put it, what's a better order of operations, do I do I punt and create a context object or something? Is that truly the correct way to do it, or um, is it more along the lines of I just need a different execution path, you know? Because I think one of the things they're trying to do here, and I don't fault them for trying to do this, is they're trying to build on top of the previous chapter so that you can then look at what was in the previous chapter and directly translate it to the next chapter. And they're trying not to do big, huge refactorings from one chapter to the next because it makes it a lot harder to figure out what's different and what's going on. The problem with that is it feels like, I don't know if this is true, but it feels like as they were writing the book, they started with chapter 1 instead of starting with the final chapter. You know what I mean? Like, if they had gone through, did this whole big program, this whole big engine, made it, look well, made it easy to grok, that kind of thing. Maybe then if they went back and started stripping pieces out and saying, okay, this is the chapter before, and this is the chapter before, and this is the chapter before. Maybe if they had done that, this would look a little bit cleaner. It's kind of a hard one because that's asking a lot, because you kind of have to, like, how does one make all those decisions and then strip them away and then still have them make some kind of sense? That's a really difficult one. So it's kind of unreasonable to even think that, but I feel like that's what a good book would do, like back to front, front to back, sort of, what is this, do the last couple chapters, do the first couple chapters, and then see if they are still meshing together into one narrative kind of thing. But we'll see. I think some of this too is, I get the impression along the way here that since there aren't a whole lot of examples in Java, they've taken most of their examples of how to use Vulkan from C information. And a lot of times they're doing like a direct translation from C to Java. And I can see that in a lot of their decisions that they've made for how they're doing certain things. And again, I can't necessarily fault them because, yeah, it's, there's not a whole lot of examples out there. In fact, this is the only good example I've found thus far, is this book. But at the same time, I feel like there are perhaps the person doing this has not done a lot of Java, right? Or at least has not done a lot of Java in the real world, right? Maybe they've done a lot of academic stuff, right? So, like, their use of things like straight up arrays when an array list would be more appropriate, because they then use these arrays, and then whenever they want to do anything important with those arrays, they have to then wrap them with, a stream and then do the stream stuff on it. It's like, well, if you made the decision from the jump to not do that, you'd be better off. This JSON stuff that they're doing with the combination of JSON and binary files, it's like, just throw it all in JSON. And if you really want it to be binary, do JSON B, It's just little stuff like that kind of I wonder about as I'm going through here. The nice thing will be, though, when theoretically at the end of this book I'll have something usable, at least have a framework that's usable. And the nice thing about that is, in theory, I can start to do small incremental refactorings and immediately test it and see, okay, does this still work? Does this fail? Does this still work? Does this fail? That's a lot nicer, especially early on like this where it's not really, the engine's not doing a whole lot. So we'll see. I'm excited to get to that point because I feel like at that point I will begin to understand this a little bit better, and understand more to the point. I'll be able to understand the interrelationships between a lot of these things a little bit better once I start picking them apart and seeing how they break, you know? But anyway, so we need to do Vulkan utils, copy matrix to buffer, device, projection matrix buffer, scene, get projection matrix, and then 0. Okay. And then we've got this dot fragment storage layouts, descriptor set layout, device, new descriptor set layout info, VK13, VK descriptor type storage buffer. Wait, do I start with that or do I start with something else? No, I do that. Okay, and then 0, 1, VK13, VK shader stage fragment bits. Okay, so that's in there, and then we gotta do texture sampler info. Did I do? No, I think I just I just passed these directly into the new texture sampler. So, so we'll do this dot. Actually, I'm gonna do this dot texture sampler. I don't have that in here. Did I miss that one? Yeah, it's private final texture sampler. Did I miss that one? Oh, yeah, I did. Okay. Texture sampler. There we go. All right. Oops, come on, texture sampler. Equals new Vulkan texture sampler. At device. So address mode would be VK13 VK sampler address mode repeat. Border color be VK13 VK border color int opaque black. Hip levels 1. Anti-trophy true. Okay. So we got that. And then the texture layouts. Vector set layouts. Device. New. Vector set layout info. Boom, 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 boom. Set layout info. Descriptor type CDK, 13 DK. Root type combined image sampler. 0. Texture cache. Max textures. DK. VK shader stage fragment bits. Okay. So that's that, and then we're down to pipeline, which was already there before, but pipeline has now takes the descriptor set layouts that we just did, right? Which is what it's complaining about right now. I think. So this will take a list of, okay, descriptor set layouts. So what is it doing? Vertex uniform. So did I not? Why is that not finding it? Vertex uniform layout. Why is that not? Am I missing something else here? Push constant ranges. And descriptor set layouts. I have push constant ranges. Oh, is this, do I have the wrong? No, that's correct. That's the opening. Oh, this is static, right? Did I make these static? For crying out loud. Okay. Why did I make that static? Probably because they made it static. There it is. That's better. That doesn't need to be static. I don't think at all. And it's private. Why would it? Yeah, never mind. Anyway, text uniform layout. Storage layout. And texture layout. All right. Creates the pipeline. So that's what gets passed into that. Good. And we've got Yeah, crate pipeline. Oh, the push constant range is different. Push constant range. Constant range is, there's two of them now. So VK shader, stage vertex bit, offset is that, and then this is just matrix 4x4 size. Alright, and then constant range. Alright, get that to go. Why will you not go where I want you to be? Alright, anyway. Okay, 13. Shader stage fragment bits. Constants. 4x4 size. Constants, 8 size. Okay. So we have those. And then that descriptor set layouts, descriptor set layouts. Huh? Wait a minute, where? What am I looking at here? Pipeline, build info. Push constant ranges. Pipeline build info. Did I not add? Oh, because they did it as a builder, right? Oh, no, because they don't take the push constants ranges there. They set them after the fact. Well, they're setting most of the stuff after the fact. Set depth formats. Did I add all of that to? Yeah, I added it all to there. Yeah, that's right. Because I just made it a record. They made it a Pojo. It didn't need to be one. Alright, that explains it. Explains the difference. Although they've got a create render info here. And create shader modules. Wait, what's it? No, where am I at? Oh no, never mind. I have those. Never mind. I'm all confused. We're back in scene render there. I'm all confused where I'm at. So that's our errors there. There's one related problem, which is here. I need descriptor allocator and scene. So I'll need those done in here at least, or passed into here. Alright, so that's looking render. So then materials cache, texture cache. Positioning textures. That's in the init. Load materials. Material cache gets passed in there, and then engine context. So where is the I've got render here. This is chapter 8, yeah. Okay. Okay. So I have to do all the things that they do in here. So this is where they create the descriptor allocator in here. So you got I'm just seeing instance, device, surface swap chain, pipeline cache. All right, and then descriptor allocator. So we can make a thing for here. Allocator equals new descriptor allocator, physical device and logical device. Okay, so device, physical device, there. Okay. And that's part of the cleanup. So down here where we do descriptor allocator, pipeline cache. I don't think I cleaned any of those up. That's not good. Swap chain. Where do I clean up the swap chain stuff? Oh, here's the swap chain. So I need to clean up the pipeline cache. And their allocator. Swap chain, surface, device, and then instance. I don't actually clean up the physical device, which I should probably do. Oh wait, does the... I think I clean it up in here, don't I? Oh yeah, I clean it up in there. Never mind. Never mind. Thought of it. It makes sense. If you're going to clean up the logical device, you might as well do both at the same time. Unless there's some reason to keep it around, I don't know. I doubt it. Okay. And then resize. Do I have that in here? Resize. On resize cleanup, swap chain cleanup, surface cleanup, surface swap chain. Alright, I'm guessing most of these probably stay the same. Okay, so I've got that. Add that in there, which means I can pass that descriptor allocator now. Go into here. Device, descriptor allocator, and then scene. Alright. And descriptor allocator is down up here. Okay, good. Is there anything else in render? So the texture cache. Material cache and texture cache. Did I do anything with those? So model cache, texture cache, material cache. Texture cache, material cache. Okay, I got those. I have those set up. Alright, anything else here? So in the init is where we have to, we're loading the models up and stuff. So we load materials. Okay. So init, we load materials and then transition the textures. So I'm going to see that over here. Alright, where? So I've got init models. Where's this called from? Engine init models. Okay. I don't have the load yet, but okay. So init models, which I think is what they call here, right? Init. Yes. Alright. Alright. So loading materials. So basically what I'm taking here, instead of the model lists, I'm taking the converted thing. Convert model. Alright, and then we'll do Loading materials first. Models. Wait. Where does the... Where's the model data come from? Logic and knits. Oh, for crying out loud. They have... It's in their main method here. All right, load model. Material data. So don't I have the yeah, it'll be the mesh data, right? It's just pulling in mesh data, vertex path, index path. So for my purposes, yeah, okay, hang on. I think about this for a second. I mean, I only have one model right now, but I will have multiple models at some point, and so because you'll have I mean, yeah, I have multiple models. Although I only have one model per file. Because there's no point in having multiple models in one file. So that'll be outside. So I won't have like a parent class that has like a list of converted models. I'll just build that when I load all the different model files in. Presumably I'll have some kind of like manifests that would say like, here's all the files to load and for this scene, and or here's all the models to load for this scene, and so on and so forth. But we're not there yet. Okay. All right, let me mute the mic for a minute and transition to sitting down, and I'll turn the webcam back on. So 1 second here. That's a little bit better. It feels good to stand, but also like feels good to be able to back down again. Anyway. Oh. Like I need it. Like I need, this is what I do during the day. Like I stand for like an hour or so, and then I try to like not be sitting for more than a few hours at a time. More than like 2 hours or so, if I can help it. Just to keep on my feet, keep a little bit active. I mean, as active as standing in one space, in one spot can be, I guess. Anyway. Excuse me. Okay, so I need to translate this to what we're actually doing here. So loading materials. Which is including the textures. Okay, we passed the texture cache in there. From the texture path, which comes from the material. Okay, which comes from the material. So do I have the texture path in here? I do have the texture path in here. Do I? So I must be, yeah, I must be setting it. Yeah, I am setting that. ID, texture path, diffuse color, yeah. Yeah, okay, so those are in the material. Alright, so then we're loading materials. Model dot materials dot size. All right, and so then we're loading that into the materials cache. Material cache. Load materials. Device. What is it? Device, materials, texture cache, pool, and queue. Device. Get materials. What else is it? Texture cache, pool, and queue. And pools 0. And graphics queue. Okay. So we're loading materials there. Here. Oh, duplicate. I don't care. Okay, so then load materials. And then transitioning textures. For texture transitions, device, samples, get first, graphics queue. And then loading the models. So we'll do this would be converted model. It's really just the one. This is all for that model, so it's really just loading model. Really, right now. Okay. And so load models takes a list of Vulkan model. You need to convert the thing into a model, into a Vulkan model, right? Let me see. Mesh. Is that what we were doing before? Add mesh. Okay. Mesh lists. Vulkan mesh data. So I have the Vulkan mesh data. So what I want to do here, I think I had mentioned this before. I want to do a override here. Public void and meshes. Mesh data. Mesh data lists. For each look at mesh data, data in mesh data lists, call add mesh, device ID, data. Yeah, okay, we'll do that. And then that will let me do, when that pops out there, dot add meshes, device, converted model dot get mesh data, or sorry, ID. Which would be what? What ID normally be? Would so Vulkan model, what is that ID? Is that just the mesh ID? Yeah, it's the mesh ID. I'm trying to think of what we did in the last one. What did they call mesh IDs in the last one? What did they say? Mesh data. Yeah, they just said like cube mesh. Right, so it's not like a huge deal. It's not, yeah, it's not a huge deal what it's called. So I thought, didn't I put an ID in the mesh data? I have a material ID there. I think they had a separate ID, right? In their mesh data. Yeah, it had a separate ID from the material ID. Let's put that in here. Private string ID. Which just means I need to track down this material ID little converter. And then they had a model loader, what did they call it? generator. Yeah, they did a string ID. So I'll put that down here. String material ID or mesh ID is what do I call it? Mesh dot m name data string plus underscore s mesh positions. I'll just say position there. And actually, let's just do this properly. Okay. Helps to spell it correctly too. And then I'll do return data, set ID, mesh ID. Alright, do that, and then get back to here, and we'll say each mesh, so the ID will be so I don't need to pass an ID in here because we're going to pull it off the list. So I'll just do data.getID. There we go. That's better, hopefully. So add meshes. Where are we at over here now? Still in model. So that's our model there, and then so load models would just be list of the model. And the rest of that stays there. And so the materials. Materials. Scene render load materials. Hold on. So why did I put oh, I see. This is what I meant. Scene render. Load material. That's happening. That's happening at the end now. So I'll even have a load materials. Did I miss that in the scene renderer here? Oh yeah, that's brand new. And the cleanup, they have direction matrix and stuff too. Let me get back to scene renderer. Create, so cleanup is pipeline and injection matrix buffer, cleanup, vertex, whoops, vertex uniform layouts, cleanup, fragment storage layout, cleanup, texture layouts, cleanup, texture sampler, cleanup, and then we got rendering infos, attachment info depth, and then we're freeing up the push constant buffer. Okay, good. So then we have a new thing here, render. Materials. That's a public. Okay. So public void load materials. Tool cache. Texture cache. Good. And what else? Descriptor allocator. Oh, we need the descriptor allocator. What do we need? We need the device and descriptor allocator. So put that in here. So we're doing descriptor set. Var descriptor set equals allocator dot add descriptor set device descriptor IND materials fragment storage layout. Okay. Layout info. Okay, that's from the fragment storage. Layout info binding and layout info. Okay. So var layout info equals fragment storage layout dot layout info var buffer equals material cache dot get materials buffer. So descriptor set sets buffer. This buffer gets requested size, layout info binding, layout info, descriptor type. Okay. Vulkan image view. Views. Texture cache. Get as lists. Texture, get image view. List, okay. So we're reusing descriptor set. I don't like that. Where are we reusing that? Set images array. Okay, they're just using it to. They're just bringing it back in order to set things in it, but its descriptor set stays in there. All right, that's definitely something that's going to change, because that's confusing to look at. Because whenever you're reusing a local variable like that, that's bad news bears. That means you're doing some nasty code. Let's see. Image views. So descriptor set equals allocator gets or allocator.add descriptor sets, device, descriptor ID, texture, texture layout, sets, images array, device, image views, texture sampler 0. What's going on there? Texture sampler. Right, okay. What's the problem here? Required type texture sampler provided Vulkan texture sampler. Did I never fixed this. That's the problem. This should be okay. All right, very good. So that is now correct. That is load materials. And then render takes a materials cache in addition to the models cache. Cache, material cache. Wait, do I? Wait, it takes material cache, but nothing else changed. Materials cache. Oh no, because they added descriptor allocator in there. I fixed the push constants, right? Yeah, added those in. I think I did under resize. Just make sure here while I'm looking at it. Where's resize? Render info, color depth, measurement depth, color. Oh, we do have a copy here. Welcome utils, copy matrix to buffer, device. Projection matrix buffer. Oops. Scene. Which I don't have in here. Scene. Pass that into resize or into resize. That has to be passed in now. Dot get projection matrix and 0. Alright, and then this has to get resize. The only place that failed there? I guess that's the only place that failed there. Okay. Okay. So, we have that. So then render itself. That's command handle, image barrier. Begin recording, bind pipeline, set viewport. Scene get entities for each. Model cache, get model, set push constants. much as this has changed is the next question. Model Vulkan mesh list. Number of meshes. Did that change from the last time? So that part didn't really change, but the part around getting the material has changed slightly. If I missed the descriptor allocator up here after the vertex thing, so vertex buffer, descriptor allocator. I think this is in set viewport here. No, set scissor and then offsets. And vertex buffer. What's that used for? Oh, they're used down there? Offsets is used down there? Bind vertex buffers. Command bind vertex buffers. Oh, that's inside there, the offsets and the... Oh, right, which I think I moved... Offsets and the vertex buffer. I think I moved those into... something else. I think the bind meshes I moved them into. Yeah, offsets, vertex buffer, blah blah blah. Right, so then the descriptor allocator just comes. Hopefully it doesn't use those. No, it doesn't use those, so it's not tied to those at all, so that's good. So that can just go up here then. Allocator. Oh, we're passing it in. Are we passing that in right now? Not yet. We're gonna have to though. Because I don't have that in here, do I? No, because we're passing it in. I wonder if it just... Thinking of whether it would be worth it to just store it in here. But we'll hold off on that. So descriptor allocator is getting passed in now. So right here, descriptor sets. Command bind descriptor sets. Command handle. We didn't. That's not. No, okay. Alright, so do long buffer descriptor sets buffer equals stack malloc long 3 put 0 allocator get descriptor set ID projection dot get ID put descriptor set descriptor ID materials ID IntelliJ, please. Just put things where they're supposed to be. It's not that hard. Allocator descriptor set texture get ID. So I had that, and then VK13 VK command bind descriptor sets. Command buffer. So command handle. VK13 VK pipeline bind point graphics. Gets layout ID 0 descriptor sets buff and then null. Right? Okay. Okay, that's something. We have that in there. And down here in this area, okay, bind meshes. So yeah, so we got set push constants there, and then vertex buffer put. It's not new, is it? So I already had the set push constants they had before the loop. And then they pushed it into the loop. Or that, which I have it in the loop. Which I think is correct. Model matrix. Manhandle. Yeah. All right. So in bind meshes here, I go and do materials cache. Oh boy. Number of meshes. For each Vulcan mesh. What are we doing? We're doing material ID, materials cache, get position, material ID, material cache, get material, material ID. Huh? Material. DID. Wait, what? Wait a minute. What are they doing here? So you added so you have a material ID. Go into the material cache to get the index of it, and then they're going back to materials cache to get the they're getting the material, and they're getting the index of the material. Okay. And they're setting the push constants there for the material index, the model matrix. Okay. So what they did was they moved the set push constants down to the material level because it's going to change for each, or because we're setting them. If I'm reading this correctly, we're setting variables, which are basically uniform variables, that the shaders can then have access to. And so what we're doing is, instead of pushing the last model that we had, all the textures on all the sides were the same. This one has different textures on the different sides. So we're setting variables for all the different textures so that the shaders can then handle each of the face of each face of the cube correctly and map the correct texture onto each face. Okay, so if I'm reading this correctly, so that means I have to. And they're pulling it out of the materials cache. Do I have... They're not... Are they not putting stuff into the vertex buffer anymore? Am I... I mean, they still should be, right? Because you want to clean those up after you've copied them over, right? Yeah, vertex buffer put. Yeah. Okay. Okay, so they're still doing that. They're just doing the push constants in here, which would be... How would I do that? I'm in, see, this is the problem. They have this up at the scene render, but I'm in Vulkan model. Well, I can still do it. What I can do is move, because this is the only instance of push constants, right? Right, okay, so then I will move the set push constants into Vulkan model. Let's just grab this whole freaking thing. And we'll put that into Vulkan model here. But it needs... So what are they doing? Entity, model matrix... It needs the push constants buffer... Matrix material index. Does that not projection matrix? Do we not? Oh no, that's still past that. Okay, it's model. Is matrix for? Okay. No, there's a model matrix, and then so we don't bring the projection matrix in anymore. We just use the model matrix. Did that change? Did that change? This is scene render, right? Projection matrix. Yeah, it did. Okay, so it's just model matrix now. They got rid of the projection matrix. It's just model matrix now. And material index. Okay. Okay. So we get rid of this. And then it's material index. So then this is model matrix get 0. And I still need the push constants buffer. Which is what? Byte buffer. It's a byte buffer. We free it up towards the end. Slice. Say what? Slice? Okay. But everything... Is this the only... There's 6 usages of push constant buffer. 1, 2, 3, 4. And then creating it. And so creating it, freeing it. And then the rest of these are just in here. 1, 2, 3, 4. 4. Okay. So thinking I can just move the push constants buffer into the model. Does the model have a cleanup method though? It does. So can I, when I initialize the push constants buffer, what do I need for it? Just the size. Okay. So what if I move that up in here? Let's see. So private static final int push constants size is Vulkan utils Vulkan constants choose 4x4 size plus Vulkan constants int size. Okay, and then byte buffer push constants buffer, so private byte buffer push constants buffer. Right, and I'll just take these out of here so it breaks. So I know everything that breaks there. And we'll do, so when we start up the model, it's the only thing I see potentially wrong with this. If there's multiple like when we get multiple models in a scene, we'll have multiple push constant buffers, which I don't think is, which I think is what they're trying to avoid here by putting it up here. I don't know if that's going to cause me issues having multiples. I mean, I imagine it will. If nothing else than memory issues. So I wonder if I mean, right now it's not a problem, but I foresee it being a problem. This is, where do we clean this up at? When the scene itself is cleaned up. I'm trying to think here. I can do... I mean, I can pull the push constant. I could make a handler. And just say push constant's handler. And just make it static. Make the push constants buffer static, or at least put a static method on it that does get instance. And whenever I need it, I can just call get instance on the handler, and that'll give me the initialized push constants buffer. And in that way, I'm not creating multiple buffers. I'm always using the same one, which I think is what they're getting at here. Like using the same one across all the models. Unless the next chapter is like, hey, we're now moving this down into the model level. But if that's the case, then that won't be that difficult to do. I think I'm leaning towards that just because it's basically the same functionality as here, but it's decoupled from the scene render. kind of, sort of. I mean, I'll still call memory util, I'll still call free on it, but I'll call it in another method. And then that way my models can all just call out to that buffer to get it, and then I can move this set push constants into the model where it seems like it makes more sense. And I think that'll give me the best of both worlds, potentially. So let's see, if I do, so under model, let's do a class, we'll call it Vulkan push constants handler. All right, and I will grab this. Put that here. And then grab the size. Put that here. Okay. Yeah, okay. And then we'll do a make this private so you can't instantiate it, and then we'll say public static byte buffer get instance. Let's say if shit, because it's that. Well, that's fine. We can make this static. If push constants buffer is null, then we do the stuff up in the constructor here. So we say push constant, not this, push constants buffer equals memory util malloc push constant size, and then return push constant buffer. Then we'll put a, so get rid of that line. Right. And then in the, we'll need a cleanup. So we'll just say public static void free, and I'll say memory util mem free push constants buffer. Constants buffer equals null, just to make sure, so that if we ever call get instance on it again, it will work properly. All right. So then in here, I would just say, whoops, that's, wait, did I remove that from here? Whoops. I was making changes to the wrong thing. Whoopsie doodle. Whoops. Yeah, so that would then give me, so where am I at? I'm at Vulkan scene. So I gotta make the changes here. So scene renderer. Yeah, here we go. So in scene renderer, I get rid of this. Right. And I get rid of this because we don't need to push constant buffer in here anymore. Get rid of buffer itself. There we go. Get rid of that. And then that means down here, what I can do is call push I guess it's Vulcan. Push constant handler. 3. Do that. And down here, this comes out of there. It goes into bind meshes. Okay. All right, so we're back here. After taking the long way around. We're back here. I need to get back to render. Where was it at? Okay. Right, so their set push constants, they've changed. So then, material index, so model matrix, push button, okay. All right, so, let's do light buffer, push constants buffer equals, let me push constants handler dot get instance. There we go. And so that's that one. Model matrix get 0 push constants buffer. And then push constants buffer dot put int Vulcan constants matrix 4x4 size material index. Okay. And then command push constants. Command handle. I do need the pipeline though. Pipeline, get pipeline layouts. Vertex shader stage vertex bit 0. And then it would be push constants buffer. Whoops, let's do some next line. Push constants buffer dot slice 0 to Vulcan constants matrix 4x4 size, and then the same thing pretty much for the shader stage fragment bit. And then that is Vulcan constants, matrix 4x4 size, slice from Vulcan constants, matrix 4x4 size, Vulcan constants, int size. Okay, so now I just gotta figure out how to get the pipeline there. Pipeline layout ID. I think this is just a long, right? Most likely. Yeah, so I'm just going to pass that in as a parameter. So we'll say int pipeline layout ID. But the trick is we still need to call it from in here, which means I need to pass the pipeline layout ID into here, into bind meshes. And I think, well, no, I think the other thing is fine. So, pipeline layout ID. So it's vertex buffer put, and then before vertex buffer put, it's set push constants, command, entity get model matrix, where the frick did that come from? Entity get model matrix, number of entities, size. Do I have that somewhere here? Where does that come from? Scene get entities. I feel like I skipped the entity stuff because there's only one in the scene. Let's see. I do have an entity here. Where do I... Cube entity, cube entity. I have an add entity to the scene. So it's in Vulkan scene. Vulkan scene get entities. Oh yeah, it is scene get entities. Oh shoot. D. Oh, did I make it an int instead of a long? I did. Model matrix. So what are they trying to do? And these model cache get model. Model get Vulkan mesh list. Get model matrix. Do I have that on entity or do I have that on? I have that on entity most likely because that's where it would make sense to put it. Entities. Okay. So they loop over the entities, which makes sense. And they pull the models out of the cache. And then the meshes for the model. They loop over the meshes. They grab the material for the mesh out of the cache. And then they set the push constants for it so that the shaders can handle it, but the shaders need the current orientation of the model, which is the model matrix, I think. So get model matrix. It's just a matrix 4F, right? And I am looping over the entities in the scene. So I have access to the entity because I'm doing model ID to get it off the model cache. So really I just have to pass... Okay, when I bind the meshes I have to pass the model matrix in. I think is all I need to do here. So if I do matrix 4F model matrix, right? Then I theoretically should be able to model matrix, and then pipeline layout ID, and then I need the index, the material index. Which, how did I get the material index? Material cache get position. Material cache. I still haven't pulled the material cache in yet, have I? But I think the material cache is going to be in here. Because we're looping over the meshes. We're looking at the material. So they have this material DID, which I wasn't sure what that was. I have a material ID. I'm going to assume the material ID is what it is, and that's just a typo. So we'll do string material ID. That material index is material cache, which we don't have access to. I'm gonna have to pass the material cache in. I guess, yeah. Honestly, these are caches. Shouldn't I handle the caches just the way I handled the other thing? Like, because get material cache. Because we have a material map here. Yeah, I'm kind of wondering if, because they're caches, and caches by definition really should be available everywhere, theoretically, because it's just a cache and you want everything to be able to pull from the cache when it needs it. So I'm wondering if this is a time to do the same thing here instead of passing it all over the place. I mean, the only downfall to that is I'll have to downfall to that is I'll have to call get instance dot cleanup. I mean, it's a little bit longer to type it out, but like every time I need it, theoretically, I mean, it doesn't have to be that way, but every time I would need it, I'd have to call get instance. It's not that big a deal. Yeah, you know what? Let's do that. Let's do that on all the caches. Static material cache get instance. Private static material cache. If material cache is null, new material cache, turn material cache. This becomes cache get instance. Although, I don't know how often we're using it in here. Using it a lot. Yeah, we use it a fair amount, so that's probably not bad to do. And then this way we ensure we're always getting a singleton on it, because the cache really should be a singleton. Same with the texture cache and the model cache. They really should be singletons. I mean, if I were doing this in Spring, it would be a singleton by default, and I would just be auto-wiring them in and not giving another thought to it. So this will work. Oh, that's interesting. I just noticed something. Yeah, I guess I'll have to let Corey know about that. The, when I look at the, Alora's, activity feed, it's not in local time for me. The chat is in local time. The activity feed is showing up in, I'm guessing, UTC? Because what did it say there? 3:16 a.m. That happened a while ago, right? That was probably around 10. So that would be, we're what, 5 hours behind? So that would be, Eastern time is 5 hours behind, I think. So be 11, 12, 1, 2, 3. Yeah, that would be about, yeah. So 3:16 a.m., 10:16 p.m. Yep, that's what it is. I'll have to let them know about that. The activity feed is showing up in Universal Coordinated Time and not in my time zone. I just happen to notice that now. It's fun. But you know, I wonder sometimes if that's just something that pops out for me because of all the full stack stuff I do for the day job. Just like little things like that just kind of pop out because it's stuff that I've run into hundreds of times. It's like, oops, forgot to translate this to local time. Because ultimately what you mostly do in the back end for things is you tend to keep everything, like I tend to push us to always keep everything in UTC in the back end, because that way you always have a common thing to translate from. You have stuff going in that's in like UTC, and then you have stuff going in that's in like the server's default locale, which could be, you know, if it's co-located, it could be anywhere. You know, then everything just starts getting to be a freaking mess, right? So you try to keep everything at least common on the database side of things, and then the trick then is you just got to remember to convert things over, which is harder to remember than you might think, because it's just like you tend to take things for granted as you're going along, you know. So, and things get missed, you know what I mean? That's just the way of it. Things just get missed sometimes. And it's still, you know, the good thing with that though is it's still accurate. It's just you have to do the translation in your head, you know. So it's not like the data is bad. It's just the display of it is not optimal. Okay, so pass the allocator in here. There's that. What else is it? Oh yeah, I was in the middle of doing that. But okay, so I've done that. This takes the model matrix now, so if I do e.get model matrix, there we go. So that works. And then down here, for the material index, so I want to do material cache, get instance, get position, material ID. Okay. Yeah, I don't, normally I tend to shy away from like get instance and stuff, but for certain things it makes perfect sense. Like when you're, like I said, like when you're dealing with caches and stuff like that, it makes more sense to do it. Because because theoretically you're going to be accessing that cache from a lot of different places along the way. It just gives you the flexibility to do it without driving yourself nuts as you're doing it. But yeah. And that gives us the material index, theoretically. And what do they do with the Vulkan material? It's null, just says it does not have material, continue. Is that it? We don't pass that material anywhere? Okay, so you're just doing that to make sure that it exists. Okay. Wouldn't it be better to just say... exists? Yeah, I feel like I'm going to make life a little bit easier on myself. I'm going to say, come in here and I'm going to say, get material. Public boolean material exists. Material map contains key D. Alright, and that allow me to, so I don't have to pull the whole object down when I'm not using it for anything. So I say if material cache, the instance material exists, material ID, and I'll say if it does not exist, then logger, which I did not set up because I just didn't. Should set that up. Auger, Warren. Um, and that is mesh that no. Yeah, mesh.id and D. There you go. I don't think I can do a continue here. Oh, well, for each, yeah, I probably can. No, it doesn't like that. Yeah, I didn't think it. I didn't think it would like that. Okay, that's fine. Because what we'll do is, let's say else. Which should provide the same coverage there. A little bit uglier, but it works. And then push constants. So then this is material index. There. Why does that show up in? Oh, I know why. Because we're inside of a yeah. That's why they show up in purple. I don't know. Okay. Set command, bind vertex buffers, mesh, get buffer, one, indices, vertex buffer, get buffer. I think all that is still the same. So hopefully that's good now. I can go back up to here. And we have end rendering, and then we have image barrier, soft chain image, blah, blah, blah. Okay. So I think that's good. I think somehow I pulled that out of the jaws of defeat. I think I'm not going to pat myself on the back just yet, but I think I've pulled that from the jaws of defeat. So load materials, scripter sets. Okay, I just did that. So then who calls load materials? Oh, that's what I was here for in the first place, right? So that's in init. So if I go back to Vulkan renderer, so scene render. So models loaded. So then scene render load materials device allocator. Material cache, texture cache. Which technically I don't have to pass around anymore, but we'll do it for right now. Okay. So init materials I don't need. We'll get rid of init textures too. Because technically that's happening here. Texture cache and all that stuff. Yeah. I would like to pull those back out, but we'll leave them in one thing for now. Okay, so we have the load model here, which has to change. Was there anything else in render that changed? Texture cache, material cache, load materials. No, okay. I think we're good there. Now I just need to load the actual model up, which they are doing in their main method, I believe. Okay. So I have the cube entity still. And a whole bunch of other things. So that's loading the model, which we now have to load from a file. So string model file. Which I could just up here, private static final string model file would be what did I do for the other ones? Shaders. I think I have it at the top level here. Yeah, I guess it doesn't hurt to put it there. So we'll just say models cube. JSON. this will now return a converted model. I still need to make the entity and stuff. So in addition to loading the model. So model loader, load model. So we do here load model file. Is that okay? Okay. And an entity takes ID, model ID. So the model ID will be converted model dot I never brought the model ID in, did I? Where did they put the model ID? Is the question. Put it in the model data, obviously. But where did they read in? What the hell? Oh, it opened up a freaking MD file. No, I don't want that open. No. Close that again. So their model generator. Where did they put the ID at? I assume it came up with the ID from the file name, probably. Yeah, model file get name, model ID, which I'm pretty sure I was also doing. So where did I put that? Is the good question. So where's that? Process. So here's the model ID. Process material, model ID. Output file is model ID. Okay, I just never stored it into the converted model. Okay. So let's just add that while we're here. Just say, because I don't need these offsets. So let's get rid of these. So I'm not using them. Right, and we'll put private string ID. And get rid of this and just regenerate it. So do insert, getter setter ID, and then we'll insert toString, boom. All right. And the toString that I'm doing is not strictly necessary for any of the JSON stuff that we're working on. It's just I'm using it because it helps out a lot when you're trying to debug stuff, and the debugger doesn't need it. But if you're, when you want to say dump things out to the log, it's a lot easier to just log the whole object and just let toString go down and print out all the stuff inside of that object. So the objects inside that objects inside the objects all the way down the line. It makes for a gigantic log line, but at least you get to see everything, you know, at a glance. Though it's something you do have to be careful with. Like in this case, I don't have to worry about security, but you know, when you're doing something in the real world, you got to worry about like, well, what exactly am I dumping out into the log file? Am I dumping anything into a log file that could potentially allow attackers to gain some information that they wouldn't otherwise gain, or otherwise would be harder for them to gain? You know, like they would have to hack the database to do it or something like that. Is there anything in there that could potentially be PII, like personally identifiable information, or worse yet, like, you know, financial information or stuff like that, protected health information, like all that stuff you got to be very careful about, because it's very easy to fall into the pattern where you're just like, it's just a debug message. We're not going to have debug logging on in, you know, production. Or you just say, it's just a debug message, I'll remove it, you know, after I'm done testing, and then you just forget, you know. So it's, you got to kind of really be on the ball with a lot of that. And even the best of the best forget, you know, like it just, something got introduced, you know, especially if it's you know, you're talking an application that's been going on for years and years, right? Like someone put that log message in there back when there was nothing nefarious in that object, and then over the years something nefarious gets put into that object, and the person who put it in is not the person who did the log message, so they didn't even realize that it's getting logged out, you know, that kind of stuff. You know, I think that's a thing that people don't account for, is that even really cautious and really on the ball people will make little mistakes that are honestly not fair, right? Like they're going to be held accountable for those mistakes because they didn't realize that they changed something that had those implications. But on the other hand, it's often not fair to them to be hit with it because they had no reason to believe that was happening somewhere else in the system, you know. Especially when you've had a system that's been going on for years or decades, or, you know, got a ton of code in it, and sometimes you just, you know, you can't have, when your code base is thousands of lines, you just cannot store all of that context in your brain, right, for a long period of time. It just, especially given that those lines of code, those thousands of lines of code are changing constantly, you know, through other people's hands, and you're not, you know, hawking over them. You might be doing code reviews for them, but again, to try and keep a code review in your mind of someone else's code while you're developing your own code is just, you know, I think that's unreasonable for even genius level people. You know what I mean? Like even people with like photographic memories, I think that's even unreasonable for them. You know, that's just the way it is. It's just try and keep all that context in your mind. And honestly, that is probably one of the things, and this is kind of the, not to get on the AI topic, but this is kind of the one of the more frustrating things about the direction that these AI companies are pushing. They're kind of going with like this, what feels like a shotgun method, where they're just like, let's hit every angle of this that we possibly can. You know, we've got this giant side of the barn. Let's make sure it's covered in holes. Um, when they could have really been looking at the novel ways of using the AI as it currently is, because this shotgun method is really showing how bad our current implementation of AI is, because it's failing and miserably in a lot of different use cases. But there are a few where had they focused on these particular novel use cases and put their effort into them, it could be extremely useful. And one of those is being able to look at the entirety of a application, the entirety of a code base, and being able to look at new changes coming in, look at them in the context of the whole code base, and try to predict troublesome areas. Or at least try to predict breaks in, or try to identify breaks in like the normal coding format, or even like patterns that are diverging, say, you know, like say there's a pattern that's emergent throughout the code base of a certain way of doing things, and then someone else comes in and does something completely different, and you know, maybe that's something that would be flagged as something like, well, is this a better way of doing it? Should we be doing this elsewhere this way, or is this not taking into account this other thing, and it'll make it that much more difficult to grok later on from, you know, other people when they come by and try to have to modify that piece of code. Stuff like that, I think it could be very useful for. I think often when I have AI sort of summarize code, like summarize a collection of classes or a package of classes, it often does a decent enough job of it. You can't trust it at all. But it can at least give you a bullet point outline of things. And if nothing else, tell you the order of operations, which I think is extremely useful. I think if we could get AI to basically be, so one of the hardest things to do, and it's something you do repeatedly, is when you're starting up a new feature, or you're doing, you know, you're tagging on to an existing feature or something like that, you're in an area of the code base that you either haven't been in for a while or you've never been in. And one of the hardest things to do is to wrap your mind around the flow of the code and what's happening and why it's happening and what flags are affecting it and what variables are in play and that kind of thing. Most of the time what people do is, well, first of all, they'll read through it. But second of all, they'll fire up a debugger and try to trigger that code and then like follow through as it goes line by line to try to help them visually see what's going on. And what would be a really novel case for like AI stuff would be have AI look at the flow of a particular function, look at the flow of a particular feature, really. You say, here's our feature, here's the classes that participate in it. Tell me how this works, or generate me a flow diagram or something visual, tell me in text, in paragraphs, how does this work? What steps does it take? What checks does it make? What external variables does it look at? That kind of thing, and just have that be able to summarize that for you in a human readable format. Like, that could be damn useful. Again, can't trust it, but it'd be damn useful. So it's stuff like that I think those are, I think, the cases where the current state of AI would probably shine better and be less of a hindrance to everything, right? The problem is they're trying to be everything to everybody because they want to create a culture of fear in the executive suite. They want executives to be afraid that they're going to be left behind, and that's exactly what they're doing, right? They're saying to the executives, "Oh, you're going to be left behind if your company's not doing AI this and AI that and AI this. All your revenues are going to dry up. You're going to be, the analysts are not going to be on your side. You're not going to be on the magic quadrant where you want to be, and the which is just a paid for bullshit thing anyway. But it's like, they hear all that stuff and they freak out, and when they freak out, they don't think, and that's what's happening a lot. Is that they're the execs are all freaking out, saying we got to do this, and they're not really putting any actual thought into it. So all the things they're doing are not particularly novel or useful to their users more often than not. And the analysts love it because they have no idea what they're looking at. They think, oh well, in their minds you're bleeding edge now, so you're cool, and we should give you thumbs up and attaboys and all that stuff. And the execs love all that stuff. But at the same time, they're not really listening to their engineers who are being like, you sure you want to do this? Because this is not going to work the way you want it to. And on the flip side of things, a lot of us are very excited about the prospects that AI can do in certain cases, but I think there's a lot of people we're all very skeptical, I think, because we've seen how bad it can get, how bad it is. But I think the problem is you have a lot of software engineers who are not able to push back and say no when they should be, or at least not be able to be convincing as to why this is not a good idea. And so a lot of them are just kind of plunging forward, trying to just make everybody happy because that's what we're told to do. And they're not really taking a step back going, why this is insanity, why are we doing this? Or they are, but they're not making any headway. You know what I mean? Because again, they've created this culture of the AI bros have created this culture of fear in the executive suite, and so they're not really thinking straight. Even when we're saying no, they're saying yes, and they're not hearing the no's. They're hearing, in their minds, it's damn the torpedoes, we gotta go. And it's that's why I keep saying I hope this bubble burst sooner rather than later, because it's the longer it takes for it to burst, the harder it's going to be for a lot of these companies to rip out all the bullshit they're now tied to. Because when it bursts, these AI companies are all going to they'll all consolidate into one big conglomerate. Some company with a ton of money will go vacuum them all up for their IP, and then most likely discontinue most of the service or jack up the price of it to ungodly levels. And then you're going to have a lot of companies eventually, realize that, how screwed they actually made themselves. And then it'll be a process of, well, now we can't remove this feature because then it looks like we're idiots. It's like, well, maybe you need to do that. Maybe you need to just go in front of your clients and be like, look, we thought this was a good idea and we were very wrong, and we're going to make this right. we're going to take the L on this one and just do better. Yeah. But we'll see. We'll see how it goes. So got in there, converted model. So then right after I create this, I'm going to do converted model dot set ID, set model ID. There we go. I'll make my life a little bit easier. Yeah, because then I can use that for the entity here. Alright, so convert model to get ID. And 0, 0, -2. Put it in the same spots. And then we'll just return convert model. There we go. Value of parameter model file is always block engine cube model file. Yes, I know. I realize. But thank you for telling me that. I told you. All right. So I got that loaded up. Was there anything else in their main here that's about it. They just grab the scene. Is that used? I'm not sure why they grabbed the scene. Are they using that for something? Oh, they're okay. Yeah, they're doing it to add the ND. Okay, never mind. Never mind. But there's no other change here, which makes sense. So, do I have any other to-dos? I have padding texture path. To do, fill this out. Where's that used? Adding texture path is redundant. Yeah. What did they set? So that's in texture cache. Record. For texture transitions. Oh, right. That's transition text. So what does that default texture path? Perhaps get property default texture path. What is their properties set for? Resources models default PNG. Resources models default PNG. Oh. It's just a black texture. Okay. And that's all they did was... Texture path. Okay. So... Out loud. So what I'm doing, I think I was just doing models, default PNG. There we go. Make a models folder. Let's copy. I'm just going to copy theirs over. Paste that, and then you've got the cube model. I think that was the last to do that I had, right? Yes. Okay. They have their cube model. Where's the where do I put the stuff in it? Vulkan engine. Let's load model file. Yeah, I did models cube JSON. Okay, so models directory cube. All right, I'm going to go over here and I'm going to grab their object file. and their PNG. Oop. No, I actually, I don't want to. There we go. I don't want it associated with anything. All right, and I think their cube object has the cube PNG in there. Maybe not. We'll see when we have to run a test here to JUnit test to just parse that file, make sure it parses correctly. Also, I don't have anything here to actually check to see if the files exist and then do the actual conversion either. Like, I'm just assuming the model exists, which is not a bad thing to assume per se, but probably should check somewhere, see if the models have to be generated. So I can say is maybe I put that in the model loader. Say, if not exists half of model file. Then we'll do a private convert file. We call model converter process file. Java IO exception. We do logger debug. I don't know if I want to debug there, but we'll see. Model converted model file, not model file. Not found. Generating. And no, you know what? Screw it. We'll just throw IO exception here. I'll say, that's static, right? Just put in there, like so. So it'll generate it if it doesn't find it. Although the convert, problem is it's going to have the wrong file. I'll look for the JSON file. Yeah, I can't really do that right now. I would like to do that, but I can't really do that right now. It'll just have to be something you run. Something I run separately for the moment. Or at least run it as a command line option. Yeah, that would be better. Yeah, do it from the main. Do it from the main method. Yeah, so on Vulkan, because what I want to do is look through the whole directory probably and look at things that need to be converted, but for now it'll just be a particular file name. Convert model file name auditor info model file and say model converter. This is file name. Process model file so convert model file command args. Where's my command args here? Okay, so what am I doing? Private string convert model file. Option. Did I do the right option there? Yeah, args for J. Name. M. Usage is name of model file to convert. Okay. Convert model file. So, should parse argument, blah, blah, blah. Alright, so we'll say if command args, no, command args get, nope, let's try actually doing this properly. Put a getter on convert model file. There we go. So if string utils is not blank, command args convert model file, then what is the thing? So we'll do convert oh right all right. So convert the one file that I've done here. If not, there we go. And I can say if file conversion error out, it's when error converting model exiting, and just return. All right, do that. I still want to do a JUnit test to test it first, outside the context of everything else, because I have very little faith that everything I've done is going to actually work up to this point. So at least I can test that in isolation. But before I do that, let's make sure. I'm sure there's some changes to their shaders, right? Oh yeah. So fragment vertex shaders. Shaders. All right, so max textures, keep in sync manually with Java code. Max textures 100. Okay. Okay. Texture coordinates, out fragmentation color. Boy, this remix of FTL music is fantastic. Who does this? This is really good. That's really cool. Cold Boot, it's called, by 744. That's fantastic. That's a really good, like, re-upping of, like, a remixing of FTL. It's really, really cool, because you can definitely hear all the Ben Prunty stuff in there, but then just kind of take it to a different stage. That's really cool. That's really, really cool. In fact, you know what? Can I favorite this? Oh, that's the wrong one. Damn it. I missed it already. Where the hell is the search? Cold Boot. Yeah, this one I like. I like that one. That one's nice. Cool. Alright. Sorry, that was just, I'm like, as that's playing, I'm like, man, this is really this is really good. Alright. So we have a structure in here. Alright. Vector for diffuse color, mutant as texture. Index, mutant, adding 2 here. Do that. And a layout, that's 1, binding 0, read only, buffer, material uniform. Materials. Okay. Layout set to binding 0 uniform sampler 2D. Textures. Layout push constant. Uniform push constant. Layout offset is 64. Material index. Push constants. Alright, and then in main here, we're saying material. Materials. Push constants. Material index. I do love that, at least in IntelliJ, I'm getting command completes in shaders and stuff. That's really nice. If material has texture equals 1, then the out fragment color is texture. Text sampler material texture index in texture coordinates. What the hell is texture? Oh, material dot texture index. I was like, what the hell? Okay. Else out frag color equals material dot diffuse color. Okay, so that is the fragment shader. This is the vertex shader. Alright, fusion 0 in position in texture coordinates. Out texture coordinates, and then we have layout set 0 binding 0 uniform form. Wait. I think that's okay. Okay. And layout, push constants, uniform PC, matrix 4, model matrix, push constants. Field position equals okay, so this would be instead of projection matrix, it's projection uniform dot matrix times the push constant small matrix times vector 4 in position 1. Out texture coordinates equals in texture coordinates. Okay. So I've made those changes, so I haven't forgotten that. Yeah, the only thing left now is to do those JUnit tests to make sure I'm loading and writing the object, like I'm parsing the object file correctly and I'm creating the correct files. And then after that, it's attempt to run the whole shebang and see what I have forgotten or missed along the way. Alright. But my friends, that's not going to happen tonight because we are burning the past midnight oil right now. So I am going to commit what I've got. And almost finished chapter 8. About to commit CRLF line separators to get repositories. Huh? Is that because of my... CRLF line separator. I don't know what it was, which one it was complaining about, but whatever. Because I can look and see if there's anything, any problem here. Yesterday? Did that not commit? Did not push my commit out? It did not push my commit out. It's a good thing I checked. There we go. Nice. All right. So far, so good. Be nice to be able to push this down to the main branch as well at some point. Because I mean, chapter 8's where we ended up last time. So it'll be nice to push that down and just kind of get rid of that stuff, and then I can start to use the branching to start doing, like, I'll probably do subsequent chapters as a branch and then merge the chapter down, because what got me into trouble in the first place is that it was like the book code changed and I ended up seeing the updated code instead of the what was there, and so if that happens again, I want to be able to just toss that branch out rather than having to go back in time, branch off of that, and then come back. Although it still might not help because if I have to go back several chapters, then it's not going to do anything. But we'll see. We'll see. Anyway, friends, that's going to do it for me for tonight. Thank you so much, everyone, for watching. I think tomorrow is going to be, we're going to do our usual Sunday, taking a look at some games I haven't looked at before. I have, I believe, 2 games lined up. We'll see if we get to both. I don't know if we'll get to both or just do one. But yeah, I think we're going to take a look at some new ones or some like demos and things that are out there that I haven't looked at before. And we'll take it from there. And then I guess Monday we'll be back in Dragon Quest 2 HD 2D remake, whatever. And we'll play it by ear for the rest of the week there. I would like to test Soulframe as far as streaming it, because we've had trouble with that in the past. I think I've found the issue, and I'm hoping that we can have a full stream uninterrupted of Soulframe. That would be fantastic. I've been trying to do that for ages and ages, so it'd be nice to have that. So we'll see. We'll take it from there and see where we're going. But that'll be sometime next week, probably. Maybe Tuesday, maybe later. We'll see when I'm in the mood for it or whatever. But yeah, that's the story as I know it right now, my friends. If you happen to run across this on the YouTubes and you have a like and or a subscribe that you can spare and toss my way, that would be really swell and awesome. It helps out tremendously, and I appreciate it greatly. Otherwise, thank you so much for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
Kokainom.